Exponential functions are functions of the form f of x equals a to the x for some number a greater than 0. If the a is greater than 1, these functions increase very, very rapidly. It's explosive growth. And if the a is between 0 and 1, then they decrease rapidly. These functions are often used to model population growth, especially the growth of bacteria, also sometimes the spread of viruses, etc. Let's have a quick look at how we might use these to model bacterial growth. Suppose I want to model the growth of a population of bacteria with an exponential function f of t equals some constant times some other constant a to the power of t. Then, of course, I'm wondering what is c and what is a. My model is not very useful until I found those. And suppose I observe that the population of bacteria starts at time equal to 0 with 1,000 cells, and it doubles every 3 hours. How can I use this information to find the c and the a? Well, first of all, when t equals 0, I know f of 0 is c times a to the 0, which is c, and I also know that that's 1,000. c has to be 1,000 here, so I know already that f of t is 1,000 times a to the t for some t. I also know that f of 6 is equal to 4,000, and f of 3 is equal to 2,000. So I know that on the one hand, f of 6 over f of 3 is equal to a to the 6 minus 3, and on the other hand, it equals 4,000 over 2,000. This gives me, or this implies, that a cubed is equal to 2. And of course, this says that a is the cubed root of 2, or 2 to the 1 over 3. Let's plug that back into our function. We get f of t is c, which is 1,000, a, which is 2 to the 1 over 3 to the power of t. And of course I can multiply those powers, and I get it's 1,000 times 2 to the t over 3. So that's my exponential model for the growth of the population of bacteria here. So we include logarithmic functions here because they're often used in modeling, especially to dampen down numbers in data, for example, earthquake data, but they're also used to model growth. Notice that they don't grow as quickly as polynomials or exponential functions. And here we show logarithmic functions defined for x greater than 0. And they're defined as follows. Log to the base a of x is equal to y if a to the y equals x. It's the power of a which equals x. For example, log to the base 2 of 64 is 6, and that's because 2 to the 6 is 64. And log to the base 8 of 64 is 2, because 8 squared is 64. You have the graph of two of these logarithmic functions. Log to the base anything, log to the base b of 1 is always equal to 0, because b to the 0 is always equal to 1. So they all meet here at 1. The higher the base, the smaller the function will be for x bigger than 1. Lastly, let's have a look at some functions and see if we can classify them according to our classification. So pi to the x, this is an exponential function. It's f of x equals a to the x with a equals pi. F of x equals x to the pi is a power function. It's x to the n with n equals pi. X squared times 2 minus x cubed is a polynomial. If I multiply the x squared and the x cubed, I get the degree of this thing. The highest power will be x to the 5. Tangent minus cosine is a trig function. And f of s equals s over 1 plus s is a rational function. It's a polynomial over a polynomial. F of x equals x cubed minus 1 over 1 plus the cubed root of x is not a rational function, but it is an algebraic function, which is basically a mix of x's and constants put together with pluses, minuses, square roots, division, multiplication, powers, etc., etc. Here, just for reference, we include the graph of tangent of x, and this is equal to sine of x over cosine of x. Anywhere that cosine of x is equal to 0 is not in the domain of tangent of x, and these are all these points which are all odd multiples of pi over 2. So it includes pi over 2 minus pi over 2 minus 3 pi over 2, 3 pi over 2, etc., etc. And you can see here on the graph of cosine that these are exactly the points where cosine of x equals 0. And another graph that you want to keep in mind is the graph of the absolute value of x. And we've looked at this before when we looked at piecewise defined functions. It's basically composed of two lines, the half of the diagonal of the plane and half of the off diagonal of the plane. And if you want to be creative, you can always create some beautiful dance moves with the graphs of your functions.